Okay, this is a 5 by 5 augmented matrix problem. This is actually problem 17 out of the current set of problems, which is 4-8. And notice that the title I put up here is Solution of Up to Fifth Order Systems. It's possible to use this program that's designed for 5 by 5 and use it for solving 4 by 4 or 3 by 3 or whatever you want that's up to 5 by 5. If you did a problem like this on your own, up say like 10 by 10, you could use it for anything all the way up to 10 by 10. You don't have to only use it for 10 by 10s. I'll show you how to apply these to smaller problems after we finish the implementation here. Okay, we're going to just go straight through and do it the way we did for 3 by 3. So first step is take the top row, divide through by the lead coefficient. Okay, so equals that divided by that, and putting the dollar sign on the denominator version. So it's an absolute reference in the denominator, it's a relative reference in the numerator. We've been over that a few times. Okay, so that's our first row. Now we want zeros everywhere else here. So here I want to get a 0, and I'm going to do it by taking the lead coefficient here, which is a 2. I'm going to multiply this entire row times 2 and then subtract this row. Okay? And so when I'm referring to the row, I want it to be relative so I can drag it across. But when I talk about the lead number, I want to make sure that's absolute reference. So I say equals this with a dollar in front of the A, okay, times this, and I want to pin down the row because I want to make sure it's the row that has the 1 out front. So put a dollar there. So this times that, and then minus this number used as a relative reference. Okay, there we go. We got our 0. And it drags across. And this formula, in fact, all of these formulas drag down to these other rows as well. 1, 2, 3, 4, 5. Because we've programmed it intelligently to, so let's take this one out here. I'm taking $A6, which is the lead number there, times $D9, which is the current top row, the row that started with a 1, and then I'm subtracting that one, okay? So I'm following the pattern. Okay, so this is an intermediate result, and let's take that pale yellow. Okay, next stage, so equals that. Just copy it over. The top row is never going to be touched again, and the left column is never going to be touched again. 1, 2, 3, 4, 5. Okay. Okay, this one, we're going to divide this row through by its lead coefficient. So say equals that divided by that, and the denominator, put a dollar on the B. Drag it across. Okay. Okay, here I want to get a 0, so I'm taking this third row up here. So I say that number. So I say equals, and I want to take this third row here because that's the third row here, that, and put the dollar on the B, so it's the lead coefficient, times that, which is going to be a row reference, an absolute row reference, and then subtract this one with a relative reference. So B11, and then here's a B11. This one's absolute, this one's relative. Okay, drag it across, drag them down. It works for all of those. There we go. Let's highlight these. Okay. Next, notice that we have 1s here and here. We're going to have to make this thing go. So first I have to put equals that, And this first two rows aren't going to be touched again. And the first two columns aren't going to be touched again. Okay, so we're going to be working now, let's see, 1, 2, 3. I'm going to put a 1 here, so equals that divided by the lead coefficient. Make sure that's the lead coefficient. Drag it across. Here I want to make sure I get a 0, so it's equal to, we're talking about the 1, 2, 3, fourth one down, 1, 2, 3, fourth one down. So it's going to be this one with the dollar in front of the C times the 1 here with the pinned down row 23, and then subtract that. Should give us a 0, and that should be the same formula that applies to every other cell. Okay, so another stage has been knocked off. Okay, so now we're down to this cell here. So the first 3 columns and the first 3 rows are identical to what's before. So equals that. And then I'm going to drag this across the top 3 rows and the first 3 columns. Okay, leaving this cell, which is the second one from the bottom, that's this one here. So this equals this divided by itself, the lead coefficient I should say. Okay, and drag that across. And then this one, I want it to go to 0, so it's equal to this number in an absolute sense times the 1 here with a row reference that's absolute minus this number again in a relative sense. Excuse me, it's this one. Okay, that should be 25. So it's D25 and there's D25 here. Here's the absolute D and here it's relative, and then that's the absolute row for D30 here. That works, okay? And drag it across. Okay, almost done. Let's highlight that. All that's left is to make this a 1. So put a equals what's above it here. And so the first 4 rows and the first 4 columns. So these and these and all of these are fixed. All that's left is to divide this by its lead coefficient. Okay, so this is equal to this divided by the lead coefficient, and drag it across. And we're done. Okay, so that is our last stage. Now what we have to do is back substitute. So we could call these V, W, X, Y, Z. I think that's the way they did it in the book. Let me give you another option on naming. Let's call this X1. Let's call this X2. Actually, here I wanted a space after the equals. It looks a little better if there's a little space between this and the next number. The next one, here, let's just copy these down. Let's just change that to a 3 and change that to a 5. Okay, let's right adjust these. Let's left adjust these. And let's give it some color coding. I think we used teal last time. Let's do that again. So there's our color coding. All right. So here goes. X5. We start with the last one here. Here's X5, or the fifth variable, whichever name we're assigned to it, is equal to -1. So this equals that. X4 is equal to that minus that times X5. Okay. X3 is equal to that minus that times X5 minus that times X4. Okay, this one is equal to, this one, the second row here, that minus that times the last one minus that times the next to the last one minus that times just the previous one. There we go. And finally, this is equal to that minus that times this last one minus that times the next to the last one minus that times the third from the last one minus that times the previous one equals. All right. And that agrees with the solution guide, so we're home free. So put your numbers in here, get the answer here. If you're not worried about the size of this, you could expand this to be larger on your screen. Or one thing we could do, by the way, is we could take all of these cells. If I highlight them all, in fact, let's take all the cells, let's select them like that, and let's shrink the column width a bit. That way I can get a couple extra. So now watch this trick. I want to put my X's and Y's up here so that I can see them. So I'm going to take all of these. I'm going to go cut by going Control X and then paste by putting Control V. And guess what happened? It automatically adjusted for the relative positions of all those things I was referring to. So these numbers here, like this, is still talking about rows 33 and so forth, which is down here. So by moving that around after we formulated the equations, no harm done. Okay? So now you have quite a nicely usable thing. You can just enter them, you see your results. You can scroll down if you want to see the intermediate results, and otherwise not. So, how do we use this for doing a 4x4 or a 3x3? And I'd like to apply it to problem 13 in your book, which is not one of the assigned problems, but it's an odd-numbered problem here. But just to show you how you set this up. So first of all, I'm going to do this. I'm going to take the last column, and I'm going to put zeros in it, and zeros here, and a 1 here. Okay. The critical thing is I can't have a 0 along the diagonal. I have to have a 1 or anything else. That's going to be a 0. Okay. So I'm going to have, I see what happened. I made that a 0. Okay, I want zeros along the bottom, zeros along this. Here's a place where the augmentation of the matrix actually makes some sense. Let's color code the constant column slightly differently. Let's put a, make it pale green or something. So there's my column of constants, okay? So in this square part, this is actually square, all of the cells don't look square. It's 1, 2, 3, 4, 5 across, and 1, 2, 3, 4, 5 down. Okay. The last column, other than the constants, I'm going to make these all zeros, except for the corner. And this will be zeros here. I want to make the corner a 1. This basically knocks out the fifth variable. Okay. You need the 1 in the corner, otherwise you end up dividing by 0. But I just want these to be out of the way. So everything in these rows is 0. It's now, in terms of active cells, it's 4 by 4. So let's put the coefficients in there. I'm just going to type them in and then flash them up here so you don't have to watch me do all the typing. Okay, so here's what I've done. These are the coefficients for the variables w, x, y, z, if you want to label them that way, and rows 1, 2, 3, 4. The extra row, I put zeros here, I put zeros here, and I put a 1 in the corner. All right? Just mathematically. If I make this corner one a 0, notice that everything falls apart. Okay? Can't do that. I won't go into the details of why. Let's just say it involves the division by 0, and if you go through it, you'll figure it out one way or another. Okay? I've put I can have a 0 down here in the constants. That's not a problem. I just can't have a 0 here. Okay? Once I've done that, I have it set up for 4 by 4. I enter my 4 by 4 coefficients. I have my 4 by 4 solutions. I just ignore x5 down here. So minus 1, 1, minus 2, 3 are the solutions. So up to fifth order system of augmented matrices. Your challenge, if you decide to accept it, is to do this for 10 by 10. You can do it. Everything you need to know has been demonstrated repeatedly, and it's just a matter of dragging further and doing it for more steps. Okay? There you go. Create a tool for yourself.